So today we're going over Chapter 7, Section 4, which is property of special parallelograms. These are things such as squares, rhombuses, and those shapes that are regular and evenly in all of the sides. So rectangles, rhombuses, squares, definitions are... So the rectangles is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. And a square is a parallelogram with 4 right angles and 4 congruent sides. So what is this saying? This is saying they add up to each other. So if we draw a rectangle, we're going to notice that if it's drawn properly, these should be 90-degree angles, all 4 of these. But the sides are not congruent. We have a rhombus, which is a parallelogram. Actually, that is more of a diamond. Let me try that again. Which is 4 congruent sides, so these 4 are congruent, but the angles are not necessarily 90-degree. And then we have a square, which is both of those properties. It's 90-degree angles, and all of the sides are congruent. Now, I know I didn't draw it properly, but drawn good, it should look perfect. So here we have all of the corollaries for all of the shapes. So we have the rhombus one, which is a quadrilateral, is a rhombus if and only if it has 4 congruent sides. So ABCD is a rhombus if and only if AB is congruent to BC and CD is congruent to AD, and they're all congruent within each other. So it's not necessarily going to have congruent angles, just congruent sides. That's what the definition of a rhombus would be. For a rectangle, we have the quadrilateral is a rectangle if and only if it has 4 right angles. And ABCD is a rectangle if and only if A, B, C, and D are right angles. So that means all of the angles are congruent, but all of the sides are not congruent. That's the difference between a rhombus and a rectangle. And then the square is both of them combined. A quadrilateral is a square if and only if it is a rhombus and a rectangle. So it has to have all congruent sides, and it has to have all 90-degree angles. So ABCD is a square if and only if segment AB is congruent to segment BC, which is congruent to segment CD, which is congruent to segment AD, and the angles ABC and D are right angles. So again, the rhombus is just the sides. The rectangle is only the angles. And the square are sides and angles combined. So we have parallelograms which are opposite sides are parallel. So we have the congruent sides and the congruent angles. Now all of these are parallelograms because they have at least 2 congruent sides and they are parallel to each other. That is enough information for us to be able to tell that it's a parallelogram. But not all rectangles are rhombuses and not all rhombuses are rectangles. They're all parallelograms. The only one that's both is the square. The square is always a rectangle, but the rectangle is not always a square. And a square is always a rhombus, but a rhombus is not always a square. So that's a little bit, takes a second sometimes to understand that concept. But once you do, it makes a lot of sense. Now we have the rhombus diagonal theorem, which is a parallelogram is a rhombus if and only if its diagonals are perpendicular. So parallelogram ABCD is a rhombus if and only if AC is perpendicular to BD. And then we have let me write in the name, the rhombus diagonal theorem. Again, the diagonals have to be perpendicular, so it has to be given like that, so for you to be able to tell it's a rhombus. Then we have the rhombus opposite angle theorem. This one states that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So parallelogram ABCD is a rhombus if and only if AC bisects angle BCD and BAD, and BD bisects angle ABC and ADC. So what does that mean? By bisecting it, you guys remember that it's going to break up that angle into two perfect sides. So if it breaks it up evenly from both sides and bisects the angle perfectly, then it's going to be a rhombus. And then the last one is the rectangle diagonal theorem. So that is a parallelogram. It's a rectangle if and only if its diagonals are congruent. So parallelogram ABCD is a rectangle if and only if AC is congruent to BD. Now in this case, I want to point out AC is the entire diagonal and BD is the entire diagonal. They broke it up in this image into two congruent parts per segment. And that is fine. You notice they only use one take mark for both little parts. That's just because they're cutting it in the middle. Now, if they do that, that's fine. Just make sure that it is only one take mark, as it is, what's this thing called? It has to be congruent all of the sides. So quadrilateral ABCD is a rhombus. Find the measure of each angle. So they want us to find angle ACD, so this one right here. That's for 1. They want us to find angle DEC. DEC, this one right here. For 2. They want us to find EDC, this one right here. For 3. And ABC for the 4th one. All right, in order to figure out the first one, which is the one I drew in black, you have to remember the theorem that if this is a rhombus, which it is stated, the diagonals bisect the angle perfectly. So that means if this one's 62, right here, this one has to be 62. Now for the second one, we know that again, this is given as an parallel, as a rhombus. So we know all of the angles in the middle should be 90 degrees. That's one of the theorems. So that means the second one should be 90. Now, for the third and the fourth, we have to use a little bit of math. Because remember, this is still a parallelogram. So we can say that these two big angles are supplementary of each other. So we can say 62 plus 62. So 124, we're going to subtract that from 180. We get 56. So this entire angle is 56. But that is not exact. That's actually answer 4. But, sorry, in order to remember that this angle right here and this other one I circled in blue are the same because opposite angle theorems, they're going to be bisected perfectly. So we just cut 56 divided by 2. We get 28, and that's going to be half of the angle. The reason we do half is because, again, the diagonals bisected the angles perfectly. So if this one is 28 and this one is 28, because of alternate interior angles or the fact that they're both congruent, this one is also going to be 28 degrees. So this is example 2. They're telling us quadrilateral MNOP is a rectangle. So we know what are the theorems we can use. And they want us to complete the question. So for number 1, they want us to find the measure of angle PON, so this whole big one. For 2, they want us to find PMO, so this one right here. Let me draw that one better. They want us to find PL, so this segment right here. And they want us to find MO, which is this entire segment right here. All right, so let's start. So for PON, if we remember for the rectangles, all of the angles are 90, so I can just go ahead and say that's 90 degrees. Now for the second one, since all of the angles are 90, I can do 90 minus 29. And we get 61 degrees. Then for segment PL, we know it's congruent to the other segment by the theorems. So we can say that PL is also 12. But we also know that the diagonals of the rectangle are congruent to each other. So if we find this entire measure, which is 12 plus 12, so that entire thing is 24, our other diagonal is always going to be 24 because of the rectangle diagonals theorem. So quadrilateral MORE is a square. So let's try to figure out if they said for A, ME is 7x minus 3 and MO is 6x, they want us to find x. Now remember, squares are congruent all throughout, so we can just say 7x minus 3 equals 6x. I'm actually going to go ahead and move the 3 over. 7x equals 6x plus 3. I'm going to subtract the 6x. And I'm left with x is equal to 3. So that's how you find x is equal to 3. Now I'm going to erase this because you're not going to need it, or we might need it for B, but probably not. And now for B, they were saying MT is 4x, and TE, so this one right here, is 3x plus 2, and they want us to find OE. Now, in order to find OE, it's itself, again, just doubled, or you can say 3x plus 2 plus 4x equals OE. Let's do it that way since they give us more information. 2x plus 2, sorry, not equals, plus 4x equals OE. And now we can use the x that we just found, 3. We can do 3 times 3 plus 2 plus 4 times 3 equals OE. So 9 plus 2 plus 12 equals OE. So it's going to be 21 plus 2 equals OE. So we get OE to equal 23. Now, if we hadn't solved for the x before, the way you would solve this would be to, you can set equal 4x is equal to 3x plus 2. And then you solve for the new x and plug whatever that x is into this one. In this case, we use the previous x, but if we can't, we subtract the 3x, and we actually get x to be equal to 2. So if it were with a new x, we would set up this entire thing exactly the same. We would set it up as, again, 3x plus 2 plus 4x equals OE, and we get 3 times 2 plus 2 plus 4 times 2 equals OE. Again, the reason we can do that is because we know the segments are going to be equal to each other. So 6 plus 2 plus 8 equals OE. So we're going to get 6 plus 10 equals OE, and we get a new OE of 16. In the first way, we did it with the x we found earlier. But if you're not able to solve it earlier because they don't tell you anything, you can still find it by equaling the two new letters, the segments 3x plus 2 equals 4x. Because in a square, please remember that the diagonals are congruent because the square is a rectangle, so the properties apply to it as well.